Hello Algebra 1 students. This is part 1 of section 7-1 factors and the greatest common factors. Today you need to learn a couple of skills. Number 1, to write the prime factorization of numbers. Number 2, to find the GCF, the greatest common factor, or some people say the greatest common divisor of monomials. Before we start our two skills for today, you need to recall how to list the factors of a number. How to list factors of 21. When you think about 21 as a product of two numbers, you will find 21 is 1 times 21 or 3 times 7. 1, 3, 7 and 21 are considered factors of 21. 21 can be divided by any one of these numbers. This is why we consider them factors of 21. When you think about the factors of 28, you will find 28 is 1 times 28. Any number can be factored as 1 times the number itself. It's always like that. Or 2 times 14, or 4 times 7. The list of factors in order is 1, 2, 4, 7, 14, and finally 28. All those numbers are factors of 28. Another skill you need to recall before you start studying our part today is prime numbers. Prime number, by definition, is a number that have only two factors. The two factors are the number itself and 1. According to that, 21 is not considered a prime number. What is the reason? Because 21 has 4 factors. 28 is also not considered a prime number because it has many factors. So what are prime numbers less than 20? The first prime number is 2. What is the reason? Because the factors of 2 are 1 and 2. Only the product of 1 times 2 gives us 2. This is why we consider 2 a prime number. The second prime number in our list is 3. 4 is not a prime number. You know why? Because 4 is divisible by 1, by 2, and by 4. It has 3 factors, so it is not considered a prime number. The prime number only have 2 factors, 2, 3, 5, 7, 11, 13, 15 is not a prime number. It has 4 factors. You can divide 15 by 1, by itself, by 3, and by 5. 17, 19. The list is continuing, but we need to stop at the prime numbers less than 20. In example number 1, you need to learn how to write the prime factorization of a number. How to write this number as a product of prime factors only. The first method to do prime factorization is to start with the number in the top, on the top like that, 98. And you think about 2 factors. One of them at least is a prime number, and since this number is even number, so it's divisible by 2, so you need to think 2 times what equals 98. If you don't know, simply use a calculator, divide 98 by 2, it gives you 49. So 98 is the product of 2 times 49. We're gonna circle prime numbers only because we're doing prime factorization. We will not circle the 49, but we need to think about, we need to continue factoring the 49 using the same concept. One of the 2 factors has to be a prime factor. 49 is not divisible by 2, is not divisible by 3, is not divisible by 5, but it's divisible by 7. It can be written 7 times 7. 7 is a prime number, so I'm going to circle these 2 7s. And now 98 is completely factored prime factorization. You need to write 98 as a product of all circled prime numbers 2 times 7 times 7. If you check with your calculator, if you multiply 2 times 7 times 7, it gives you 98. This is what we call the factor tree. The first method is called the factor tree. We call it factor tree because numbers are like apples like that, so we call it factor tree. Method number 2, we call it the ladder diagram. You can use either the first method or the second method. In the ladder diagram, you put the number on the top, 98, and you put it in a tiny box like that. And you need to try dividing by the prime numbers in order. The first prime number in our list is 2. Since this number is even number, so it's divisible by 2, so you need to try dividing this number by 2. When you divide 98 by 2, it gives you 49. 49 is not divisible by 2 anymore, so leave the 2 and think about the next prime number. The next prime number in our list is 3, but 49 unfortunately is not divisible by 3 or by 5, but it's divisible by 7. 49 divided by 7 equals 7. Put it inside box. And the 7 is divisible by 7. 7 is a prime number, so continue dividing by 7. And now once you end with this one, you recognize you completely factored 98 prime factorization, and now you need to write the prime factorization of 98. 98 equals the product of all those prime numbers, 2 times 7 times 7. In example number 2, we're gonna find the greatest common factor or the greatest common divisor of pair of numbers. Also, there are two methods. You can use either the first or the second, up to you. But the second, I recommend the second one because the first one is only working if the numbers are quite small numbers. But if the numbers are really large numbers, I recommend the second one. Anyways, method number 1. How do I find the greatest common divisor of 12 and 18? And you might say, I know the GCF of 12 and 18. I can even find it mentally. It's 6. Yes, your answer is true, but we need to write down our steps. 3 steps to find the GCF of two numbers. Step number 1, you write a complete list of factors of 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. Yeah, you can even check these factors. 1 times 12, it gives us 12. 2 times 6, 3 times 4. All these pairs of factors give us a product of 12. So this is the list of factors of 12. Step number 2, you put 18 and you write 18. You write the list of factors of 18 in ascending order. The factors of 18 are 1, 2. Is it divisible by 3? Yep. Divisible by 4? No. By 5? By 6? Yes, it's divisible by 6. By and by what? 2 times what gives us 18? 2 times 9, so 9. And 3 times 6 gives us 18. 1 times 18. The last factor is 18. So this is the list of factors of 12 and the list of factors of 18. Step number 3. In step number 3, you need to circle the common factors between these two lists of factors. Of course, 1 is common. Yeah. 2 is also a common factor between the top list and the bottom list. 3 is common. 4 is not common. 6 is common. Yeah, I'm gonna circle the 6. 9 is not common. 18 is not common. 12 is not common. And now, guys, we need to write the GCF, the greatest common factor or the greatest common divisor. Apparently, the greatest common factor among this circled one is 6. So 6 is the greatest common factors of these two numbers. Another example and method number 2. Method number 2, we totally depend on the prime factorization of both numbers. So we need to write 26 as a product of prime factors and 52 as a product of prime factors only. So we're not going to write a complete list of factors. We're only going to write a prime factorization of both numbers. Whatever you use, the factor tree or the ladder diagram, you can take both numbers outside and think about the prime factorization of each one of them. But I know 26 is 2 times 13. Remember, both factors are prime factors. 52 is 2 times 2 times 13. If you double check with calculator, you will find 52 equals 2 times 2 times 13. So step number 1 and step number 2, you write the prime factorization of each number. Step number 3, how do I find the GCF, the greatest common factor of these two numbers? I'm gonna circle any common factor I find. 2 is a common between up and down, so I'm gonna circle this 2. 13 is also common. Yup, 13 is common between 26 and 52. I'm gonna take one single number from each pair of common factors. So from that pair, I'm gonna take 2 one time, and from this pair, I'm gonna take 13 only one time. 2 times 13 equals 26. So the greatest common factor or the greatest common divisor of 26 and 52 equals 26. Thank you guys. Hopefully you find this part of that section interesting and useful. See you soon. Bye.